Good morning, students. Hope you're all doing good. Welcome to today's class. Today, let us recap about the following topics: introduction about organic chemistry, the alkanes, the alkenes, the alcohols, and the carboxylic acid. Introduction: families of organic compounds. As we know, there are millions of organic compounds that could make organic chemistry confusing. But to avoid this, the compounds are named in a very logical way. The rest of this presentation is about four families of organic compounds. For these families, the name of the organic compound tells you which family it belongs to and how many carbon atoms present in it. Look at these two tables. If the name ends in A and E, then the compound belongs to the family alkanes. Example, ethane. The last three alphabet is A and E. If the name ends in E and E, then the compound belongs to the family alkenes. Example, ethene. The last three alphabet is E and E. If the names end in OL, then the compound belongs to alcohol family. Example, ethanol. If the name ends in OIC, acid, then the compound belongs to the carboxylic acids. Example, ethanoic acid. This is the name. The below, the second table are the names of compound, which means how many, the name tells how many carbon atoms present in it. For example, if the name is meth, then the number of carbon atom present in it, or how many carbon atoms it contains, that is 1. So if the number of carbon atom is 1, then the name is meth. If it belongs to alkanes family, then the complete name of that compound is methane. Look into the example. METHANE. METH is meth. That denotes how many carbon atoms. Here meth means 1 carbon atoms, and ANE, that is the last three alphabet, tells the name ends in ANE, which tells the compound belongs to which family. So it belongs to alkanes family, and the formula is CH4. Second is the eth, which means the number of carbon atoms it may contain is 2. So ethane, which means eth tells number of carbon atom is 2, and ANE tells it belongs to which family. So ANE belongs to alkanes family, and the formula is C2H6. Similarly, prop means 3, but means 4, pent 5, hex is 6. So these names tells how many carbon atoms present in it. Depends upon that the organic compound family name exists. Let us learn the first family, the alkenes family. It is the simplest family of organic compounds. They are hydrocarbons, which means they contain only carbon and hydrogen. The carbon-carbon bonds are single bond. Hence they are saturated. Saturated means they are unreactive. They form a homologous series with general formula CnH 2n plus 2. Please look on to the top right corner, the structure of alkenes. Let us see how the alkenes react. Usually the alkenes are unreactive but do burn well with good supply of oxygen, forming carbon dioxide and water, and it gives out plenty of heat as energy. Hence it is used as fuel. So the reaction is CH4, that is methane, plus 2O2 oxygen. So when the methane, that is alkane, burn well with the supply of oxygen and gives what? Carbon dioxide CO2 and plus water H2O plus plenty of heat energy. Hence they are used as fuels. And these alkenes are found in petroleum and natural gas. Alkenes also react with chlorine in the presence of sunlight, and that reaction is called substitution reaction because the chlorine atom takes the place of a hydrogen atom. So the chlorine is substituted. The reactions CH4, that is methane, plus Cl2 chlorine gives, in the presence of sunlight, chloromethane CH3Cl plus HCl, hydrogen chloride. So here two chlorine atoms in the reactants. So one chlorine atom takes the place of one hydrogen atom from methane and form chloromethane. Hence the reaction is called substitution reaction. These are the two examples shown the bonding of alkanes. First is the methane. So the formula for methane is CH4. So the carbon atom is bonded with 4 hydrogen atoms. And the second example is ethane, C2H6. So 2 carbon atoms bonded with 6 hydrogen atoms. And the type of bonding is covalent bonding as they share electrons. Carbon atom and hydrogen atom share electrons. So the type of bond is covalent bonding. The second family is the alkenes family. They are also hydrocarbons, which means they contain hydrogen and carbon atoms. And they form a homologous series with general formula CnH2n. They all contain C double bond C. So unsaturated. So they are highly reactive. So alkanes are saturated because of single bond. So they are not reactive or very less reactive, we can say. But here alkenes are double bond, so unsaturated, which means they are highly reactive. Now let us see the key points about alkenes. First, the alkenes are made from alkanes by cracking. Cracking means by heating under high temperature. That is, look into the reaction ethane. The formula for ethane is C2H6, which is alkane. It is cracked under more than 800 degrees Celsius to form C2H4, ethene plus hydrogen. So it is called ethene C2H4, that is alkene plus hydrogen. Second, the alkenes are much more reactive than alkanes because the double bond can break to add on other atoms, that is called addition reaction. Before going to the third family, let us learn what is isomers. Isomers are compounds with same formula but different structures. So in alkane, the more carbon atoms in a compound, the more isomers it has. That is, the formula of a compound C10H22, the number of carbon atom is 10, that is more carbon atom. Then the number of isomers for this compound is 75. So which means more carbon atoms means more it has more isomers. And in alkene, the chains can branch in different ways and the double bonds can be in different position. So isomers are nothing but the compound with same formula but different structures. So here in alkane, the compound which has 10 carbon atom has 75 isomers, which means the formula will be C10H22 for all the 75 isomers, but these 75 isomers have different properties and their structure also differs. That is the meaning of isomers. Look into the first picture of alkane. The butane and methyl propane, both are alkanes. Both has the same formula, that is C4H20, but the structures are different for both. That is called isomers. In alkene, look into the example picture. The three isomers, that is but 1-ene, but 2-ene and 2-methyl propane. All these three has the same formula but the arrangement of the atoms are different, that is the structure is different. So this is called isomers. Third family is the alcohols. They form a homologous series with the general formula CnH2n plus 1 OH. Their OH is a functional group, means they will react in similar way. Ethanol is an important alcohol with the formula C2H5OH, as it is a very good solvent and volatile and burns readily in oxygen. The two ways to make ethanol. First one by fermentation, that is the biological way. It is made from glucose, a sugar, using yeast as a catalyst in the absence of air. Yeast is a mass of living cells, as you have learned in biology. The enzymes in it catalyze the reaction. So the formula for glucose is C6H12O6 in the aqueous form, gives in the presence of yeast as an enzymes, and in the absence of air it gives C2H5OH, that is ethanol, alcohol. It is an alcohol. So the balanced equation is 2C2H5OH in aqueous form plus carbon dioxide gases evolved plus energy. And the second way is by hydration of ethene, that is the chemical way, which means hydration means water is added on. This is an addition reaction and it is reversible reaction. So look into the reaction, the reversible sign, and the phosphoric acid act as a catalyst. So the equation is, or the equation can be written as C2H4 plus water, that is hydration means what? Water is added, hence it is called addition reaction. So plus H2O gives, that is it is a reversible reaction, C2H5OH. Alcohol, that is ethanol, is prepared. Next family is the carboxylic acids. The family forms a homologous series with the general formula CnH2n plus O2. So please learn the general formula for all the organic compounds families. The functional group COOH is called carboxyl group. The two ways to make ethanoic acid are first one by fermentation and the second using an oxidizing agent. So the first fermentation is by the biological way. When ethanol is left standing in air, bacteria bring about its oxidation to ethanoic acid. This method is called acid fermentation. It is used to make vinegar. Vinegar is nothing but a dilute solution of ethanoic acid, as we have seen in our kitchen. Second method is using an oxidizing agent, that is the chemical way. Here ethanol is oxidized much faster by warming it with a powerful oxidizing agent named potassium manganate in the presence of acid. So ethanoic acid is a typical acid reaction, and ethanoic acid is a very weak acid, and the solution of ethanoic acid in water turns litmus red. So this is used to check whether it is acid or alkaline. And it also reacts with metals, bases and carbonates to form salts. Ethanoic acid reacts with alcohols to give compounds called ester. So look into the reaction. CH3COOH, that is ethanoic acid, when it reacts with alcohol C3H7OH. So OH denotes it is an alcohol. It is a reversible reaction, and the presence of concentrated sulfuric acid, we get CH3COO C3H7, that is ester, plus water H2O. Go through the textbook well and kindly find answers for these practice questions, and please complete and write it in your classwork. The practice question in the class notebook. Stay home and be safe. Study well. Thank you, my dear children.